In order to continue our discussion on finding zeros of polynomials, we're going to take a brief aside and talk about division. We want to feel comfortable with division in order to move forward with zeros of polynomials. So it turns out there are two ways we can divide polynomials. In this video, I'm going to talk through the polynomial long division method, which likely won't be our preferred, so we won't spend too long here. And then in the next video, we'll show something called synthetic. So the next video to look forward to will be kind of a simplified process called synthetic. But in order to understand synthetic division, it does help to take a quick peek at polynomial long division. So let's actually just refresh on regular old long division with numbers, just because that process, although it's probably been a while, actually sheds a lot of light on polynomial long division. So if I was asked to take 39 and divide it by 5, right, we know how to show this longhand. We can take 39, divide it by 5, and basically the process goes something like figure out how many times 5 can go into 39. And without too much trouble, we would come up with, sounds like 7 times, right? And then whatever 5 times 7 is, that's what we're then subtracting from this quantity. So 5 times 7 is 35. Just be really careful. The biggest error I see is don't forget to subtract. And that gives us a remainder of 4. Now I'm color coding because all of these numbers have a certain meaning when we write the answer of this division problem. So 39 divided by 5 could be expressed as 7 wholes, right? And then the remainder is 4, so we could express that as 4/5. So just so you can see where the pieces of that division problem go. So 7 is the amount of times 5 goes in completely, and then the 4 is what we would have called in the past the remainder. So let's just look at one example of doing this process out with polynomials. And I'll go ahead and begin with the polynomials already set up in this long division kind of idea, just to save that step. So let's say we were asked to divide 2x cubed plus 6x squared minus 5x plus 1, and we're dividing it by x plus 3. So I've already kind of oriented it in the division house, so to speak, and we'll walk through the same process. So it can get a little overwhelming, so my focus is always on how do I make the first term outside multiply to look like the first term I'm working on inside. So for a moment, let's just ask ourselves, what do we do to make x look like 2x cubed inside? And since it already has one x, we know it needs 2 more x's. Times it by 2. So it's going to take a 2x squared. It's just kind of my habit, my personal preference to put the x squared above its like term. A lot of people don't do that, but it's just my habit. So I know if I took 2x squared times the x plus 3 out front, I'm going to match up with that first term perfectly. So this is now my side work. And I just recommend it because I see a lot of common errors without it. So anyways, I'm just going to show real quick what I get when I multiply 2x squared by x plus 3. And that's the quantity that I'll be subtracting, just like we did in the previous problem. So now I'm going to subtract off the result of multiplying 2x squared by x plus 3, which happens to be 2x cubed plus 6x squared. This whole quantity is being subtracted. So just like in the previous example, I'm going to highlight that subtraction. It often gets forgotten. So that means 2x cubed minus 2x cubed is 0. 6x squared, remember to jump out here for the minus sign, minus 6x squared is also 0. And so that's not super exciting, we just have 0, but don't forget we need to drop down these other terms that we haven't touched yet. So the minus 5x plus 1 come down and give us a little bit more to do in this problem. So now my original question of how do I make the x out front look like the term inside has now morphed into how do I make the x out front look like the negative 5x that I have as my first term inside. So we know to multiply x by something to make it equal negative 5x will require a negative 5. So I'll go ahead and pop the negative 5 up top here. There's no x term, that's okay. So I'm just kind of leaving a little blank there. So I'm going to take -5 and multiply it by the x plus 3 out front to know what to subtract. So that gives me a -5x minus 15. -5x minus 15. That whole quantity must be subtracted. So working with our signs carefully, -5x minus -5x is 0. 1 minus a -15 sounds like just 16. So our remainder in this problem is 16. Whew. So to write our answer in full form now, we have all the work to support our answer. I'm just going to clear out a little bit of space and write out our final answer here. So I can say that 2x cubed plus 6x squared minus 5x plus 1 divided by x plus 3 is equal to, and this is where we put the 2x minus 5. Let me scroll up a little so you can see that. The 2x squared minus 5 in green. So that's the big part from up above. And then the way we write our remainder here is no different than what I did in the last example with the numbers. So remember, I was able to write the remainder as 4 over what we were dividing by. And I use that same technique here. So I'm just going to say plus 16, it's a positive 16, and that's being divided by x plus 3. Cool. So that would be the result using polynomial long division. What do you think of that process? It's a little interesting. Um, in the homework, we tend to focus more on this other process, synthetic division, because it's really useful for zeros. So let's go ahead and call that good for our polynomial long division here. If you have other questions, I'd be more than happy to make another video, so just let me know.